Hey folks, welcome to Advent of Code, day 16. Still in F sharp, still going strong. Or strong is a strong word. We're still going. Yesterday we had a search algorithm, a shortest path algorithm, and I had something that worked, but it was pretty slow. It was barely fast enough to solve part 1, and then we took a look at part 2, and that was something for the weekend, as I say. So that needs some performance tweaks, but we're gonna save those up for the weekend. I don't have buckets of time during the week. So today on to day 16. Packet decoder, I'm sorry. As we leave the cave and reach open waters. Oh, we're back in open waters. Let's take a look at the map first. It's always nice to see these maps evolve. But as we leave the cave and reach open waters, we receive a transmission from the elves back on the ship. The transmission was sent using the BIT system, bits, buoyancy interchange transmission, okay. A method of packing numeric expressions into a binary sequence. Your submarine's computer has saved the transmission in hexadecimal. Yes, we know what hexadecimal means. The first step of decoding the message is to convert hex to binary. Each character of hex corresponds to 4 bits of binary data. Bits transmission contains a single packet at its outermost layer. Okay. Which itself contains many other packets. The hex representation of this packet might encode a few extra 0 bits at the end. These are not part of a transmission and should be ignored. So we have some kind of layered thing. We have some kind of padding to have a multiple of 4 probably. Cool. Every packet begins with a standard header. Every packet begins, so not every message, but yeah, single packet. Okay, so we have a standard header. First 3 bits encode the packet version, and the next 3 bits encode the packet type ID. 3 bits, what is that? Not that much space for a number. These 2 values are numbers. All numbers encoded in any packet are represented as binary. Most significant bit first, sure. Packets with type ID 4. Okay, we have different types of packets. Literal value packets encode a single number. To do this, the number is added with leading zeros, multiplied by 4 again. Yep, and then it is broken down into groups of 4 bits. Each group is prefixed. Wait, is it leading zeros? Yeah, okay. Broken into groups of 4 bits. Each group is prefixed by a 1 bit. Sorry, each group is prefixed by a 1 bit, except the last group, which is prefixed by a 0 bit. I'm going to need some examples for this today. I am reading sentences that make sense, but I can't form a mental model of what's going on. These groups of 5 bits immediately follow the packet header. I'm going to also put my Christmas music a bit quieter. This needs some thinking on my part. For example, the hexadecimal string blah 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 becomes, so this is what we get. It's a hex string. We have to convert that to binary by just using a simple translation, which is given here. Or we just do a hex to binary, same thing probably. Yeah, same thing. We use 4-digit numbers at least. So this, okay, so that's the hex to binary, and then we have this thing, but that's just labels to help explain, I'm guessing. 3 bits labeled VVV are the packet version. Yep. Which is always 3 bits, yeah, and then we have TTT, which is the type ID. Literal value, cool, and then all the rest except, and then it's what the groups. 5 bits labeled A, start with a 1, so it's not the last group. Okay, that's how you need to interpret that, yeah. And contain the first 4 bits of the number. Okay, 5 bits labeled blah blah blah, still not last group, still a number. And then we have a 0, so that's the last group, and then we have a number. And we have some padding. 3 unlabeled 0 bits at the end are the extra due to the hexadecimal representation. But do we have an 8 in the end? Should be 1,000. Yeah, okay, should be 1,000. Okay, so we can just ignore whatever comes next. Cool. So this packet represents a literal value with binary representation, blah, blah, blah. Those are those 3 groups, right? 101, 11111, no. Oh yeah, these are the ones. 111, oh, 0101. Yeah, okay. It's making sense to me. Cool. This example. Oh, geez, this is a large puzzle. It doesn't look too tricky or too difficult up until now, but it's a lot of info to parse here. Okay, let's go over it quickly. Every other type of packet. So if we have another packet type ID, we don't have literal values, but we have operator. Oh no, this is a flashback to the int code years. So we don't only have literal values, we have operators that perform calculations on sub packets within. Yeah, of course. We don't care about the operators, only on the hierarchy of sub packets right now. Cool. Okay, so we can nest packets. We can nest packets, yeah. Operator packets can use one of 2 modes. Length type ID. Length type ID is 0. The next 15 bits are a number that represents the total length in bits of the sub packets contained by this packet. Whoa. Example time again. So we can have 2 different type of lengths for operator packets. Total length in bits of the sub packet, yeah, and 11 bits are a number that represents the number of sub packets immediately contained. Example time again. Finally, after length type ID and 15 or 11 bit fields, the sub packets appear. My computer is freezing up all the time. Is it this background process again? The 3 bits labeled. What? We have an example here. Yeah. So again, we have a hex. It ends up being or we convert it to binary, or we could convert it to binary to follow the example. And then we have version packet type ID. 6 is some kind of operator, but we don't care which one. Then we have the length type ID. Oh. Yeah, it's that stupid background process again. There's nothing I can do about it. So I'm just going to continue on reading. Okay, but we have the same thing, version, and then type ID with some random number, which we don't know what it means. Then we have a length type ID. It can be 1 or 0 or 1, which is the 15 or the 11-bit thing. 15 means the number of bits. And then we grab those next 15 bits. That's the length. So that's probably 15 bits converted to a decimal. 1, 2, 3 plus 8 is 11 plus 16 is 27. Yeah, makes sense. So the length of the sub packet is 27. But then I'm starting to get confused. Where is this 11? Where's this 11 thing coming from? So after LLLL, what happens then? So we are in this case, length is 0, yeah. Then we have 15 bits. That's the total length in bits of the sub packets contained by this packet. Okay. Okay, and then we have sub packets. So starting from here, we have sub packet stuff. When do we, what is the start of a sub packet? So here they say 11 bits labeled A contain the first sub-packet. How do we know that? I don't understand how you know that. So it's a sub-packet, which means do we need to parse it exactly as a packet? Or do we don't have the header in the type ID thing? The example is glossing over stuff like this, or I'm not reading it correctly, but it's confusing me. So it's a single packet that itself contains many other packets. Every packet begins with a standard header, so that means that that A thing has to start with a standard header and stuff like that. So that would mean we have a version thing, a type ID thing. That doesn't look correct, right? The type ID for a literal value should be 100. Okay, yeah, that's correct. And then we have a 0, so that's the last group. And then we have 1, 2, 3, 4 somethings. Yeah, and that should be a 10. That's correct. Okay, makes sense again. And we have a second subpacket. How do we know this? Because we have 27 bits of subpackets, and A has 1, 2, 3, 4, 6, and what was it, 4? So 10, so this should be 17, something like that. Yeah, sure. 16 off by 1, but probably correct. And then again, we need to parse that. It's again a type 100. Let's make sure it's a type 100. Yeah, it's a type 100. What do we do with the packet version? I don't think we do anything with the packet version right up until now. Okay, but I think that first thing makes sense for me. After reading 11 and 16 bits, yeah, that was what I was trying to deduce. We know we reached that thing we parsed down here, so we know this packet has stopped. This packet has stopped, but what do we do with the next thing? Do we need to nibble up something else, or is this end of message? We cannot sequence packets, we can only nest packets, so let's just ignore everything that follows in a message. Yeah, makes sense. This is a big... I don't know if the solution will be complicated and big, but it's a lot of mental parsing to get this explanation down. One that was a different thing, so that is the number of sub-packets, not the length of all the sub-packets combined, so it's a bit of a different thing. Version, sure. Packet type ID 3, which is some kind of operator, we don't care. Then we have the type length, or the length type. So length is an 11-bit number representing the number of packets. 11 bits labeled whatever are that number, which is 3. The 11 bits labeled A contain the first subpacket. How do you know that? It's version, type, and then the group thing, and it's a 0, so it just ends. Yeah, okay, that makes sense. And that happens 3 times, cool. And then we reach the number 3. So sometimes we need to count how many bits we parsed to end sub-packet parsing, and with the other thing we need to parse a certain number of packets. And then just things stop. For now, parse the hierarchy of the packets throughout the transmission and add up all of the version numbers. Okay, that's where the version numbers come into play. So let's keep track of those. And then we have some more complete examples. Okay, so we just need to parse packet hierarchy, not do anything with it, we just need to parse it. Yeah, we just need to parse it, okay. This already took 15 minutes for me to understand the problem. This does not bode well. This is an easy one, right? It's just a packet with no nesting, so I'm gonna grab that to play around with first. But maybe let's think about the types we will be using, because that will impact our design a little bit, or a little bit of a lot. Yeah, it'll impact our design by a lot. Let's model a packet. Or let's model a parsed packet first, so we know where we have to work towards. I'm gonna put that here. It's a record. We need different kinds of information, and there's is it a record? We have like a nested packet. Oh yeah, we have operator packets and literal packets based on the type ID thing. I think I might model it as a union type. So we have a what is it? Literal values, and we have operator packets. And we used to no. um, Now I'm gonna use something F#6 introduced, so it's pretty new. It's called anonymous record types, I think, but that allows you to like define recursive types, or like have a union type with its own custom data, which is itself a record type. That's something you had to do in like 3 lines of code instead of just the one, but I think this might actually be a case where this new feature makes sense. What does a literal value packet contain? A single binary number. Do we want to keep the number in binary, or do we already want to parse it into an integer or a long? A multiple of 4 bits broken into zeros. This can be a very large number in theory, right? Yeah, this can be a very large number. I'm gonna use longs, sure. Does a literal packet have anything else? Once we parsed it, it's just a number, right? Yeah, that's easier. The parsing will be difficult, but once we have something parsed, it's easy. Cool. Same thing for... No, we need versions. Sorry. That's a 3-bit thing, so that can be a small number, sure. Operators also have versions. Operators, we don't care about those. So how will we keep track of those? Doesn't really matter. We can come back to it later, so I'm just gonna keep nothing. Let's not keep track of the operator just yet. Or have them encoded as a number, sure. But then the magic happens. Subpackets. We have subpackets, which is a list of other types of packets, and I think it can be anything, right? It can be a literal value, but it can also be a nested operator, which itself is nested. So this is a recursive data type, like a tree, where we can go down to infinity if the input wants us to. I think this might be the end result we want after parsing. Maybe it will bite us performance-wise, because we are already converting to numbers, and maybe that's not something we want to do. Actually, it won't be that bad. Let's take a look at the input, see how much data we're talking. Piece of cake. Yeah, I think this strategy might work. How many characters do we have? 1,359. Cool. Yeah, now the boring part starts. Now we just need to parse. I'm going to put the parse rules somewhere. Did I put them there? I'll put them there. So this is the first example. This is the literal value thing. Parsing a version is taking 3 bits. Let's try parsing a version. What's like helper functions we need? These things will end up as unit tests in a second, but while I'm playing with stuff, I'm just gonna use the interactive window or the REPL. So let's grab first 3 bits and let's parse the version as a warm-up. Is a list the best data structure? We always need to nibble from left to right. Yeah, for now we do. So I think a list will work just fine. If we do stuff like this, we end up with sequences of characters. Maybe we want to parse our binary numbers into... Actually, we don't get binary numbers. We get hexadecimal numbers. Yeah, we get hexadecimal numbers. Our input is hex. So, but that's another step we can take later on. Let's first dig through this. Let's assume we already have binary representations. Strings are maybe not the best intermediate representation. No, strings are not the best representation. Let's do a bit of... Let's assume we parse our hex into a list of zeros and ones. And so a little value packet here. Let's transform that quickly into a list of zeros and ones. The numbers, not the characters. So if we put every character into a string and parse that as an int, I think we have a sequence of integers, which is 0 or 1. And if we list that, we eagerly evaluate the whole thing. So now we have the list. Yeah, makes sense or looks good to me. Version is the first 3, and then convert that to an integer. Now I'm thinking a list of like ones and zeros, and then converting that to a binary might not be the fastest approach. I don't care. It might not be the fastest approach because the best way I know of doing this, or at least how I do it in the past, is by converting this thing to a string again and then parsing that string into a... as a binary number, so then and then convert it to integer. But I think I'm just talking myself out of this list approach. Maybe we should stay with characters and not integers. Let's see. How do you do that again? There is a thing called system.convert from base something binary. What is it? Do we need to look up this thing? What does the convert namespace contain, or the convert class? We can parse to an int to a long. I think you can provide this thing with a base, like a base 16, base 2 thing. No? Provider from base. There we go. So we know it's base 2, and we're parsing into an int. So I think if we do this, 111 is 7 or something. Yeah, that parses into a 7, and we need a string to do that. We don't need numbers. So let's forget we parse this into integers. We don't need to parse this into integers. I am going to take the list approach, or am I going to take a string approach? Let's do the string approach until it bites us. So we just have a string, that's it, and we can do substring just as a... Yeah, we'll do a substring. And then we can convert easily. I'm gonna call those conversion functions binary to decimal because we also have like hexadecimal in here. I don't want to confuse myself. And we get a string input. There we go. So I'm just wrapping this thing in a function. This should parse the version just fine. So that should be a 4 into a 6. No, it's a 3. 1, 2, 4. That should not be a 3. What? Oh, okay, substring. That's not the index, but the length. We need 3 digits. Yeah, 6. That's better. Now that I see this, I don't like seeing this in F# code. I want to pipe all the things, so I'm going to do a substring function as well. Which takes a string, but that's the final argument to make it pipeline friendly. And then we have a start index. Should we give it an end index or a length? Let's give it a length. Let's not make the mental translation too big. So S is a string. Again, need to help the compiler here. So the only thing we just did was... Is that actually necessary? Can I do this? No, we can't do this. Like calling C# or .NET native things that are not part of the F# library, that always hurts a bit. So I often define wrappers like this. But start index, length, but then let's type it correctly. It knows which function I mean. Yeah, it knows which function. Cool. And now we can just pipe it as with any other function. Start at 0, take 3 of those. That should still be 6. Okay, we have like our basic algorithm of parsing parts of a thing. Only thing I'm thinking now is substring sucks. No, it doesn't suck. But we need to nibble up the string. So we need to have a pointer or get rid of the things we parse. And that's where a list would have been easier. Yeah, that's where a list would have been easier, actually. Can you split a string on index? No, it's all separators. Can I do something with a number? No, that's all character. Is there no standard library thing to not only do substring, but split a string into 2 parts based on an index? I don't see it. You know what? Let's do it ourselves then. I don't like this substring thing anymore. I'm torn. Should we use lists or should we use strings? I don't think it'll matter that much, so let's stick with the string thing. And instead of substring, I want to do a split on index. Split add. We have like, just remember we have an F# module called string as well. Let's see what we have in there. Replicate, map, length, iter, init, for all, concat, collect, exists. Nope, nothing useful. So split add an index and a string gives us this was correct. What is the length? Oh no, we should start at 0. Should we start at 0? Yeah, we should start at 0. And we take... If we give the index... Index is a bad idea. So yeah, it's just this, which is the first part. And then the second part is the rest of the string, which is... Now we're into off by 1 territory. Is it length? Is it length minus 1? So say we want to split at 3 as we did here. We take 0, 1, 2. I'm already confused as to why this is correct. Oh yeah, it's length, not index. Oh, it's messing with me. So it's 0, 1, 2. That's grabbed by this. And then we say substring starting at 3. Yeah, I think this works. So let's try that out. 1, 2, 3, 4, 5, 6. Split at 3. And 3 is the index, not the value. Yeah, that'll work for our purposes. So then we can do version and remainder. And we can do a split add. Split add 3. And then we have those two strings in one operation. Does that look correct? 100. Yeah, that looks correct. Now we can parse the version. Which was a 6. Yeah, still is. Cool. Okay, this took half an hour, but I think we're finally getting started with the actual problem. Then we have packet type ID, which is the same black magic. And another part of string nibbled up. We'll do this in a pipeline thing in a sec. Now it's really confusing me with all the remainder strings in here. Split add is a bad word, I'm starting to realize, but let's go with it. Is remainder correct? Yeah, looks like it. So this should be a 4 now. Yeah, if it's a 4, we know it's literal. I'm gonna use the same convention here. So text, text, and without text to be the parsed thing. So now we're here. We have a version. We have the rest of the string. We know whether or not we have a literal packet or not. Let's implement the literal case first, because that's the example we're taking a look at. Then we need to start munching groups. So this represents a single number. Yep. To do this, the binary number is padded with leading zeros. Leading zeros, not trailing zeros. Okay. So it's always a multiple of 4 bits, and then it is broken into groups of 4 bits. Yeah, okay, so we have leading zeros, groups of 4 bits, cool. Every group is prefixed by a 1 if it's not the last group. These groups of 5 bits immediately follow the packet header. I was thinking we can just use the remainder of the string. That is only true if we don't have nested packets. So we kind of need to do this if we want to parse in a single pass from left to right. So let's do that. So we just take the groups, and groups are like prefixed by 1, 1, 1, 1 until we hit one group that is prefixed by 0. That's the last group. So yeah, we just parsed VVV, TTT, and then we parse buckets of 4 while they start with 1s, and we parse one more that starts with a 0. It's buckets by 5, right? 1, 2, 3, 4, 5. Yeah. Okay. Okay, it's not hard today or not difficult, it's just a lot. I'm going to write a function again. This is an operator packet. It's a nice to-do. It'll blow up in our face once we get there. So we reduced the problem to how to parse a literal. I'm gonna put that below the example we're doing right now. Let me grab that, put that here somewhere. How do you parse a literal packet? We need to parse the thing and return the remainder. So we're again writing a parser. We've done this a couple of times this year. So what do we need to do? We need to take groups of 5. We need to take groups of 5. As long as we encounter ones. If we encounter a 0, that's the last group. How does that translate to code? To F-sharp code, even. We could do a recursive thing. We could say, so split at 5. Then we have one group. And if it's a 1, we just do this again and again and again. Yeah, I think that makes most sense in my head. So this is what we're working with. The groups of 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2. Is this correct still? 101. To make sure that we're not working with the wrong string here. Yeah, it's correct. What will we call that? Grabbed groups? Something like that. So there are groups of 5, but the first bit is only like, this is not the last, or this is the last group. It's only like a marker. And then we have unlabeled bits due to hexadecimal representation. I'm a bit worried about that part. So we're taking groups of 5, 5, 5, and we did that. Oh, maybe it's because it's the only packet, and we don't have this like we probably don't have these padding on the right. We only have that in the outermost packet to have like a valid encoding in the end. I'm gonna assume that is the case and not worry about it. The trailing 0 thing in combination with nested packets, that won't happen. So yeah, let's chunk this problem down even more, and let's write a quick helper to grab groups of 5 up until we have a 0 prefixed group. Groups is a really bad name. I choose to roll with it for a while. What is text? The string? We're still in string world, right? I don't need to do that if I have my pipe-friendly operators. So we do take 5. Or split at 5. So this is a single group and the remainder of the string. If group begins with a 0, so yeah. What is group again? String. So we can just do let's do starts with. So group is a string. Why doesn't not have auto completion on it? Okay, there we go. If it starts with a character 0, it's the last group, and we just return the 4 next digits. So then we take no, we don't take the substring. Yeah, we do. It's we know the end of this string. We just took something of definite length 5, so it's I'm gonna call the literal function because that has an overload start index 1. So if we're at the last group, we're done. Otherwise, recursion enters the fray. I'm gonna not use tail recursion. No, let's worry about performance when that becomes a problem. So otherwise we return the remaining 4 parts. So yeah, let's do. So we take group substring 1 again. Wait, that's the same thing, right? Yeah. So let's do that just once. It's not called header. What is the 1 and the 0 called? Let's call it prefix. So that is group. I'm going to need to see some examples here. It's becoming a bit too hard for my brain, so just gonna grab this and let's see here. So we split at the first 5 digits, yes. Then we grab the prefix and the rest, yes. So if prefix is what was here a second ago? A 0, okay. Then we're in the last group, so then we just return the group itself, which is a 4-digit thing. Yep. Otherwise, we have the group, but we need to find more groups which are in there. So we do group. How do you concatenate strings again? Let's try that out in the REPL here. Is it just a plus? Yeah, just a plus. So let's concatenate this with a recursive call, and this is not the most performant thing is if this happens a lot. That's why I mentioned the concept of tail recursion, but we'll maybe explain that once we get there. In F# you need to write the function as being tail recursive. The compiler will not really help you with that, or I don't think so. So what do we need to do, or what do we need to parse? I think we need to parse this. And in the last call, we will have like some snippets dangling, like those 3 zeros here. But I don't think that's a problem. So let's give this a try. What just happened? I think the correct thing happened. Let's make that a binary to decimal thing. It's 2021, that's correct, right? Yeah, that's correct. This warrants the first test. So yeah, let's write a test for this groups function. So if we parse this into groups and convert that to binary, that should give us 2021. And that is a string. I don't know how this ended up not being a string anymore. Is this the text we've been playing with? Yeah. So this should work. It works, cool. So that is encoded for posterity. We can get rid of the playground things. We can get rid of the playground things. This is also playground thing. Cool. So we are parsing literal. Where is this coming from? Did I just throw away? What is this? Let's go back. Oh yeah, I threw away the wrong example. Sorry. There we go. So we have a number as binary. Let's just do number. Now that I see this, it's really easy. We do text, take the groups we're looking for, and make that a decimal. I think we might be done. And that's even a one-liner now. I think we might be done with parsing literal packets. I'm not happy with the fact that... Whoa, what happened? I'm not happy with the fact that this returns an integer. That's not correct, right? No, that's not correct. We need to reparse or return the remainder of the string once we hit hierarchic stuff. Otherwise, we would end parsing after just the first literal packet. I'm trying to convince myself of that fact. Yeah, I think so. That's not a correct thing to do. So let's return not only the group, but let's return the remainder of the string. So this returns a tuple, and then we need to grab a tuple. So let's do a we need to do the recursive call, which returns a tuple, and then we need to paste the current group with the recursive group and return the final remainder. Yeah, this is okay. Parse literal value text returns group and remainder. Whenever you have to write parsers, you see remainders pop up everywhere, or whenever I do it at least. And we return like group parsed to and the remainder. I think now it's looking a bit worse. Oh, we're returning the wrong thing here. Thank you, syntax highlighting. That would have been a not so fun bug. Yeah, but now we have literal value here and remainder 3. I don't like my convention here. Let's not worry about recursive things just yet. Let's just return a literal value. How do you do that? Okay, this will work. So we have literal value of, what was it? Number. And version. Yeah, version we also have. Ta-ta! Literal value can be a very big number. Should we already be working with longs instead of integers? Probably. This is now incorrect. It is true. Let's fix our test. That's the first thing I should have done, actually. Sorry? Oh yeah, this is the problem. So groups should return this. And let's not do the binary to decimal thing. Let's maybe write a quick binary to decimal test to make sure it keeps working, but I don't think we need to touch that anymore. So I think this will stay safe. I think we might have just finished parsing literal value packets. Except that we also need to return the remainder, the rest of the string once we're done. Yeah, let's play around with this. Let's wrap this in a function. This is our main parser, and it parses something called text. And then magic happens, so let's write a test for that using our literal example. Let me put that packet somewhere near our tests. We don't have to pollute our tests with an actual thing, so it's what? Parse packet, literal value packet, and that should return us something. Sorry, I have not sent this to the REPL just yet. It gives us a tuple with a trailing 3 zeros. Yeah, that was correct. That's padding. Ta-ta. And it's an anonymous record because I did not want to write 3 lines of type definition. I'm already regretting it. This is a syntax I'm not used to, like this banana clip thing. It's not a banana clip. Banana clips are a thing in F#. They look like this. Yeah, these are banana clips. But they're used for something totally different than record types. They're used for pattern matching or active patterns, but let's not go there today. I think we are able to parse a single packet, and even, dare I say it, we can parse hierarchical patterns almost. I mean, like, if we make this function recursive and we just call it on remainder, I think that should just work. Trademark. But let's take one step at a time. I don't like seeing this anymore, so I am going to inline it in our tests. And I'm going to run them all just for the sake of it. This was the easy part. Now on to the hard part. Parsing a operator packet. So we know it's an operator packet here, and then we have to go down one level of choice. It was the length thing, or the number of subpackets versus the total length of subpackets. Yeah. So I think we can follow the approach we've been using here. We are parsing operator packets, yeah. And they are nested packets, or they contain nested packets. 2 modes immediately after the packet header. Packet header was the first 6 digits, right? So the 7th digit is the mode. Length type ID 0, length type ID 1. It's a total length in bits versus a number of subpackets. I'm gonna define a type for that, because it's a concept in the business world or in the problem domain. So let's encode that as a first class concept. Length type ID, total length, and number of packets. They're both numeric values, yeah. Total length in bits and number of packets. So those are the 2 different modes we have for operator packets. So let's take a look at parse. Did we have a parse operator? No, not yet. So let's do that. Parse operator packets. Maybe let's refactor this or rename this. It's parse literal value packet things, and this is parse operator value things. Yeah, sure. So what does this thing need? Needs this as well. And it'll return this and this. Yeah, what is in an operator packet again? Oof. So version that stays the same. Operator. That's something we need to parse. And packets, that's something we need to parse as well. Cool. Not sure. I'm not sure, and when I'm not sure in F#, I just play in the REPL. So let's do that for operator packets. We need to end up somewhere around here. So we need to have the version which we have, the operator which we will do just now, and then do the hierarchical parsing, which will be the most tricky part, especially with this 2 modes thing. So I'm just going to start playing with a operator packet. We have 2 examples. Yes, we do. One is the easy mode, or the total length mode. The other is the number of sub packets mode. So let's do the total length mode first. This is not the most clear name, but it's okay. So we parse VVV, we parse TTT, and starting from the I, that's the remainder we will be working with in this parser. So the first bit is the mode. So let's parse the mode first. Total length operator packets. Can I do substring? Can I do this? Yeah, we can. So why am I using a pattern match all of a sudden when I've been using if-thens for this entire series? Let's keep doing that. If total length packet is 0, what mode was that again? If it's a 0, then we have a 15-bit number. 15-bit number was what again? Total length in bits. Otherwise, no, I'm gonna do an else if. Yeah, I'm gonna do an else if, I'm going to do a pattern match instead. That reads more F-sharpy when I look at it. So we have total length in bits. We have number of packets. What was it? Yeah. And in every other case, we have a bug. Unknown operator packet length type ID, which is a character. And we need to provide a formatter. Yeah, there we go. So I think we can parse mode, or at least we can parse the mode out of it. Why is mode expecting an integer? Sorry? Oh yeah, these take an integer. Sorry. So these are like, this is it, but now we need to know the next part. What was the next part again? 15 bits for the first thing, 11 bits for the second mode. Right? Yeah, okay, so now we need to parse the 15-bit thing. So this is not the actual mode, this is just this thing. So the mode data constructor, but we need to provide the number, and that's depending on this. Yeah, that's depending on this. Should we do that just inline? Yeah, I like it in line. I'm not sure if I like it inline. It'll be messy, but let's do it. So for total length in bits, we know it's 15. The first 15 bits are the number representing the number of bits in the subpacket. Yeah. So we need to grab the next 15 bits. Let's just do a split at. Yeah, what is it? Split at what? How did this thing work again? Length. So we need to provide split at 1. And that gives us a character, which is actually a string now because we are doing substring. So this is the same thing. And this is now a tuple. Yeah, I'm gonna do this and then just print out the tuple with remaining string. And let's print out the everything we know. When things explode, like when you're writing exceptions, I always like to take a short while to see, can we provide all the information we have at this point? I hate it when software throws null pointer exceptions in your face and you don't know enough to troubleshoot. You have to start debugging. I hate it. And as a programmer, you can do so much to prevent those scenarios. If you like, just put in 10 seconds of extra effort to make the exception message clear, or to provide all the data you have in the message or the stack trace. You're helping out future you or your team members, so why not? But anyway, we know in this case we have total length in bits, which is 15. So if we split at 15, these remainder things, I'm going to write mistype one, and it's going to be one hell of a bug hunt. I will instantly regret this decision. But this is the thing we need. If we parse that to a decimal. And let's just return the rest of the string as we have been doing, because the remaining parsers need to nibble up those parts. And I think for the number of packets, that's an 11-bit thing. We can do the exact same, but split at 11 instead. We're mixing things here. It's not the cleanest of code. This. I'm not gonna worry too much about it. I should, because bugs will be very costly. So let's instead, I'm not gonna clean it up because we've been working an hour and I want to see this to the end before I have to go to work. But I want to at least have my parsing done, my part 1 done. So what I was saying is, I'm not going to clean this up. I'm just going to write some tests and write some exhaustive tests, or at least the examples we have, to make sure that that thing is working. So we should have length 27. I thought I saw that. Yeah, that's correct. And then we just do recursive calls up until... Oh no, we need to keep track of the lengths, right? I forgot about that part. Oof. Wait just a second here. So when we're eating up or when we're nibbling strings, when we're doing this recursively, we're now in a case where we know, like, okay, we need to parse 27 bits. There's X amount of sub packets in here, and they need to amount up until 27 bits. That's something we completely forgot about. Yeah, that's something we completely forgot about. We could do a dirty thing and reconstruct this, like just call the parser recursively, and then it'll parse a subpacket. And when we have that subpacket, we also have the remainder of the string, so we can do like a where in the string is this, starting from the end of the string. I think that might actually be not prone to bugs at all, so it would work, but it's not really clean, right? Should we keep counts, like how many characters we've parsed? That would be the most explicit approach, right? But it'll dirty up our parsing code. Everywhere we'll see numbers. Hmm. The number of packets one, I think, is actually easier. Yeah, number of packets is the easy case. This total length in bits, that's the tricky part. Hmm. What's the best approach here? Say we do the hacky thing. That means once we have our mode and our remainder, now we know, depending on mode, what we need to do. And in this case, we have total length 27. Oh no, we can just take the 27 next bits, of course. Forget I said anything. We're golden. We're golden. So I'm just gonna write yet another pattern match on the thing we did now. That's not something I'm gonna push into here. It's dirty enough already, so let's do another pattern match. So we can later move this on into different functions if we want to. What do we want to do? So if we know it's a total length in bits, we can just grab that many. We can just grab that many bits. I think our split that thing works again here. Split add is... don't like it. It should be split add. Yeah, it's one index based, not zero index based, and then it's correct, but I don't know what will return or what the return type of our thing is, so I'm just gonna write stuff until the compiler is happy and play around with it, sorry. So we split at, what was it? Sorry, we split at 27. So this should be a 27-digit string. Let's make sure. I see 27 and then I see me typing the wrong buttons, so now my parser is not happy. Okay, yeah. Okay. Is what we're doing correct here? Yeah, but yeah, okay, no. I think this will work. So this is sub packets. And now this is the easy thing again. So we can just parse sub packets recursively. But now, if we are going to do that, these functions need to know about each other. Yeah, these functions need to know about each other. So I'm going to grab everything. And now this will get tricky. There's like, should I write helper functions? I should write helper functions. Let's call this parse mode. So parse mode, get something, which is an operator packet. And it'll do the thing we have been designing here. Let's just return that. But it's a tuple. Yeah, it's a tuple. So I'm going to type a method signature. Otherwise, I'll forget what this thing does, and everyone will forget what this thing does. So it's a parser that parses a mode, and there's something following it, a string. It's not the clearest of code. It's a very dense pattern match still, but as I said, let's keep it as is. So if we do parse mode of our total length operator packet, that should still work, yeah. We can move our playground down. This is all things that look great. Everything below is things that are work in progress. We could even, yeah, we could even, but we should even write some checks for parse mode. So let's do that. Parse mode given this should give us something. And right now it's the 27 total length thing. And I'm going to assume that the remainder is correct. I don't want to verify that. So that's just parsing a single mode thing. That's not parsing the actual sub packets, which is what we're doing right now. Yeah, so we are back where we were, but we pushed some stuff into helper functions. Okay, and I was going to make a recursive call to parse packet, because now we have a string representing X sub packets. We don't know how many. We only know like these are sub packets. So now we should call parse packet. And you'll see if we try to do that here, parse packet sub packets, we have a problem because the F# compiler cannot look into the future. It parses files from top to bottom, and we have not defined parse packets yet. So this doesn't work. And the way to fix that is by using mutually recursive functions. It's a very horrible name. But what it means is if function A calls function B, and function B calls function A in return, which is what will happen here, they need to know about each other, and you need to define them like in a single statement. But I think maybe for now we can do this. If we don't do the full example, but we just do the, okay, operator packets can contain value packets. I think we're still good for this. No, I contradict myself. Let's do it right first time. So we have a parse packet function, cool, and then we have a which is recursive. We need to annotate it as recursive. And we do something here, yeah, which is something we'll do in a second. But we also have a function called parse operator packet. And that's where we do the parsing. And these are mutually recursive because we use this AND magic. And now I can call parse packet from within this function and vice versa. So these functions now know each other. I'm gonna satisfy the compiler just a little bit, but not too much. Yeah, so this is not correct, or not the end state, but at least our compiler is happy now. And now we can start taking a look at this mutually recursive thing. I think this is the first thing we do in that function, yeah? There we go. So this is subpackets, and that is remaining whatever. And if we parse the subpackets, we are good, and we return. So this is packets and some other remaining string. I'm sorry, I'm like jumping from the hack of the tech, as we say in Dutch. That happens when I code in F# for an hour. Things start to get difficult even for me. But this is a string. Yep, this is another string. And I think if we plug these two back together, we have the full remaining string that needs to be parsed. Not sure about that part, but we'll see. Now we're taking a really big step. I'm not a fan of taking big steps. These are just bugs waiting to happen. Got this like inkling feeling. But anyway. Yeah, I think for the total length in bits, we are now recursively calling our parser on the subpacket string, and whatever string that remains, we just leave it well enough alone. Yep, so let's now return. Do we know enough at this point in time to build a operator packet? Sorry. Yeah, it's an operator packet. We have a version, yes. Operator, I completely forgot about. Whoops. Yeah, we forgot this thing. The 3 bits labeled T. Oh no, yeah, that's the type ID. That thing we know. Where is it again? We have version and we have packet type ID. So if it's not a 4, then we're in this thing. So here we know the version, we know the operator. The only thing we need is the subpackets, which is what we just did. Yeah, cool. Yeah, but no. So subpackets here. This is a string, and we are sure that it contains a sequence of multiple packets. In the example, they're all like literal value packets, but it's a sequence. And right now we are only parsing the first one. Yeah, this is not enough. No, this is not enough. For the number of packets thing, we have like a halting condition. For the operator, the total length packets thing, we have another halting condition, but this will not work. My PC is super laggy today. Sorry for that. I feel like Father Time knocking on my door. I only have 15 minutes left. I don't think I'll be able to finish part 1 as well. It's a shame. I feel like that I'm close, but I'm not close enough to round it up. Maybe I'm gonna write a pseudo algorithm down so I don't forget, and I can take a look at it later today. To do parse all the sub packets, because right now we are not parsing more than one, and that's exactly what we need to do here. What is wrong here? I'm just gonna crash here. Yeah, let's crash here. So what parse packet? Oh yeah, yeah. Okay, there we go. So this is not correct. This will only parse the first sub packet. Yeah, but we need to do this until we have souped up, or until remainder is the empty string. So again, that's some recursion. It's nothing new under the sun. We've done this like 3 times already today. Should we try that? Hammering that out in 15 minutes? No, I don't like pressurizing myself when I don't have to. I've seen enough production incidents this week. I have pager duty at work, which means they call me when things blow up, or at least I am one of the people that has to fix things. And let's say it's been a busy week. We have some infrastructure problems, and like parts of our critical infrastructure has been falling down every day now. So tiredness is kicking in. So I'm gonna call it a stream. I'm gonna call it a quit. I think we are not stuck. It's just a big problem today. So if you're still working, if you finished the stream, congratulations, or today's puzzle. It's a big one. It's like a big parse one. Uh, I'm happy with my progress. It's not I won't be the first person to crack today's puzzle, but I always have fun with parsers like this. It's a fun thing to do. But anyway, so today we didn't even solve part 1 due to lack of time. Uh, but I'm feeling optimistic about this one. We'll get there. Thanks for watching. See you again on Advent of Code in F#. Bye bye.